Okay, let's go ahead and begin. You have your first homework due on Thursday. Are there any questions on the homework? Is that going? Anything we need to address there? Doing okay? Okay. Okay, today what we're going to do is we're going to get back to talking about random variables. And we're going to focus on an important random variable in statistics called the normal random variable. And the normal random variable is very useful in statistics because when you look at the distributions for many quantitative variables, for example, for a quantitative variable, if you can construct a histogram using a lot of observations for that quantitative variable, you often see that the distribution can be well described or well approximated by a normal curve. So this is not always the case, but it's quite common that you can see that the distribution for a quantitative variable can be well approximated by a normal curve. So the normal distribution is quite useful in statistics. And what we're going to be interested in doing is using the normal curve for approximating some probabilities of interest to us. Okay, for example, we can look at this example here with the heights of college women. So data suggests the distribution of heights of college women can be modeled by a normal curve with a mean of 65 inches and a standard deviation of 2.7 inches. So we're using this normal curve to approximate the population distribution for this variable. And suppose I ask a question like, what if I randomly select a female student at random from this population? What's the probability that her height will be greater than 67.7 inches? So remember this right here this is a density curve. So the area under the whole curve is 1, or 100%. So if I draw out let me just draw it out over here. $65. That's not right, is it? It's 50. What is it? Is that right? Does that look okay? Any disagreement there? Oh, I've got something wrong. What is this? Oh, this is 50. I'm sorry. 59.6 and what? 56.9. Okay. Okay, so I'm going to label this height variable just by the letter x here. And suppose I want to figure out, again, I randomly select a female at random from this population. What's the probability that her height is going to be greater than 67.7 inches? So we want this area, we need to figure out this area under the curve here. Now, if some of you have had calculus before, one thing you might consider is using the function that defines this curve and, using your integration technique. If you've had calculus before, you can use your integration techniques, but the problem is your standard integration techniques aren't going to work for the function that defines your normal curve here. You'd have to use kind of numerical integration techniques. So we're going to make use of a table that's going to help us out in terms of giving us the area under the curve. But to answer this, though, let's just use those properties I gave you the other day for normal distributions. I said that for any normal distribution, approximately what? 68% of the observations lie within 1 standard deviation of the mean, approximately 95% lie within 2 standard deviations of the mean, and approximately 99.7% of the observations lie within 3 standard deviations of the mean. So using that information, how would you approximate this here? What would you tell me about this area right here? We know 68% within 1 standard deviation of the mean. Here we have a symmetric curve here, symmetric about the mean here.
32%.
So what would you tell me about this right here? This area here, what would you tell me?
32%.
You'd say 0.32? She's shaking her head over here. You don't agree?
This 32 would be either side of the mean.
So what do we know? What do we know about this area right here? This area under the curve between 62.3 and 67.7. That's our 0.68, right?
So then it's 16.
So we'd have what? You could say over here, I think 0.1, that would make more sense, I think, right? 0.16 here, 0.16 here. Is that okay? What about if I asked you probably that x is between 59.6 and 62.3? What would you tell me there? What would you tell me there? Anyone want to help me out with that one, or? So if we can figure out, the area to the left of 62.3 and subtract from that the area to the left of 59.6, that'll give us what we need, right? So what's going to be the area to the left of 62.3? That's going to be the same as the area to the left of 62.3 is going to be the same as the area to the right of 67.7, right? Okay, so we have the point, we can take our 0.16 and from that subtract what? The area to the left of 59.6, the area under the curve to the left of 59.6, so what is that area? So we know we have 95% fall within what, 2 standard deviations of the mean. So we're going to have what? And what left is 5% remains, so we're going to have 2.5% over here, 2.5% over here, right? So you can so right here, this area right here is going to be what? Around what? 0.025? So if you take the 0.160 minus 0.025, that should give us what we need, right? Does that make sense? So you got 0.1, 0.135. Does that make sense? Now we're going to end up using a table that's going to help us out in terms of figuring out our probabilities, but I just want to kind of get you into the idea of thinking about area under the curve. And are you okay with what we did here? Okay. Well, let's see how we're going to make use of a table. The table I'm going to make use of is called a standard normal table. And let me show you what a standard normal table looks like here. This table right here gives us the area underneath a specific normal distribution called the standard normal distribution. A standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. Standard normal distribution. And we usually use the letter Z to denote a standard normal variable. So our standard normal distribution looks like this. And what this table gives us here is it gives us the area underneath this standard normal curve to the left of some positive z value. So here are our z values along here. This table gives us the area underneath this curve to the left of our positive z values. Now along the top here is the second decimal place for our z-scores. So for example, if I wanted the area under this standard normal curve to the left of, let's say, I'll just say suppose I want the area underneath this curve here to the left of 1.28. Suppose I want this area right here. So I want the probability that z is less than 1.28. And there's one thing I'm going to point out here is that when you're dealing with a continuous random variable, it's not going to make any difference whether I write it like this or if I write z less than or equal to here. It'll be the same, because if you think about it, we're defining probability as area under the curve. And what's the area under the curve above a single value? There's really no area above a single value. So whether we write it like this or this is not going to change our probability there. And this is for a continuous random variable. But anyway, that's kind of just a technical point there. But so suppose we want this area right here. So how would we figure it out? Well, you just go to the far left column here to get your z-score. So 1.2, and along the top to get the second decimal place. And then so the area under the curve to the left of 1.28 is what? Where is it at? Right here? 0.8997. Does that make sense? Just using the table there? Is that okay? Now I give you another standard normal table that's going to give you the area underneath the standard normal curve to the left of the negative z values. And actually, you could really just get by with one table because you can use the fact that the curve is symmetric. But anyway, made your life a little bit easier here. So I gave you this table here. This gives you the area underneath the standard normal curve to the left of the negative z values. So just remember these two tables I've given you, they give you the area to the left. Area to the left of a z value. Okay? So if you want the area to the right of 1.28, what would you do here? You know the area under the whole curve is 1, or 100%, so you would just do, if you wanted this area, you would just do 1 minus this will give us this. Does that make sense? Okay. Okay, so we've talked, so now you see how to use the table here. Now let's see how we're going to apply this table to some kind of real life applications here. So let's go back to this situation here. And let's just suppose that we don't know those properties that I gave you earlier about normal distributions, and suppose I just want to figure out this area here. Let's see how we can make use of our standard normal table to help us figure out this area. So let's compare. What I want you to do here, I want you to compare these two distributions here. These are both normal distributions. Okay? Now what can we say about, so this area right here underneath this normal curve is going to be the same as what area over here? The area under the curve between what and what? Just comparing the two, they're both normal curves here. So this area here is going to be the same as what area over here? The area under the curve between what and what? Negative 1 and 1. Negative 1 and, oops. Negative 1 and 1. So this area, same as this area. So what we can do, so we can convert over to our standard normal distribution, then make use of our table to figure this area out. If we know this, we know this. Okay? So the usefulness of the standard normal distribution is this. It provides kind of a nice reference kind of distribution. Because, I mean, in practice, you're not going to find many variables that follow when you look at the raw data, you're not going to find many variables that follow a standard normal distribution. Where this comes into play, where this is useful here is any normal distribution you're working with, you can convert over to your standard normal distribution and make use of this table to figure out what area you need. Okay? So now let's get back to our task at hand here. Suppose I want to figure out what's the probability that x is between 62.3 and 67.7. 62.3 and 67.7. We've kind of shown that this is going to be equal to what? The probability that z is between negative 1 and 1, right? But how do you, so now the negative 1 and 1, we just kind of figured out those values just from looking at the graphs. But how do you, what's a way that we can convert from your x value to a z-score? What we can do is we can take the x value, 62.3, minus the mean for your distributed, which is what, 65, divided by what? Your standard deviation, which is 2.7 in this case. And you can do the same with the other, 67.7 minus 65 divided by 2.7. And that'll convert to your z, so your z is between negative 1 and 1. And this is discussed in your, in the lecture notes. Right here. The formula for converting any x value to a z-score is you take the value minus the mean divided by the standard deviation. And what does the z-score tell us in words? A z-score measures the number of standard deviations that a value falls from the mean. If the z-score is positive, the value is above the mean. If the z-score is negative, the value is below the mean. So 67.7, the z-score for 67.7 is 1, because that 67.7 is one standard deviation above the mean. Okay, so but now let's get back to, let's figure out how to use our table to figure out this probability here. So what are we going to have there? Let's go back to our, tell me how to use the table. And try to print out your, start bringing the standard normal tables to class. Let's go ahead and okay, there you go. So what am I going to do? How can I figure out this area right here? You want to help me out? What approach can I take here to figure out that area right there under the curve? What do you think? Well, one way I could do it, if I can figure out the area to the left of 1, and from that subtract the area to the left of negative 1, that'll give us the area that we need, right? Does that make sense? So what is the area under this curve to the left of 1.00? I'll carry more decimal places out here, 1 point, okay? We can go to our table here, right? So what are we going to have? What's the area to the left of 1.00? 0.8413, right? So if I take, so to calculate this probability here, this is going to equal what? The probability that z is less than 1 minus the probability that z is less than negative 1. Does that make sense? Right here? So the area to the left of 1 is what? 0.8413. And then from that, we can subtract the area to the left of negative 1. And what is that?
587.
Well, we can just go to the other table. Or again, you could actually just get by with one table, but we don't, using the symmetry and all that. But okay, so minus the 0.15. So this is going to be 0.1587 here. And what if we take that difference there, what do we get? You can go and get out your calculator there and 0.6826. And that 0.68, that should make sense to us, right? No, because we learned that what? Approximately 68% within one standard deviation of the mean. Okay, so. Okay, the important thing here though is, do you see how we use the standard normal table? Right, we started with a normal random variable, then we converted to a standard normal, and then we made use of our table to figure out the probability that we were looking for. Is that okay? Here, let me give you, I'm going to let you try a few here. Now on my web page, I have some kind of there's some in-class exercise folder here, and we've got one on, should be one on, maybe not, let's see. Yeah, in-class exercise, just labeled in-class exercise 1, I guess. So let's look at some of these. What is it now? Are we okay? So let's take a look at some of these. Wait a minute here. Let's take a look at this. I mean, number one here involves a uniform distribution. We can come back to that one. That's just like the bus stop, but we can come back to that one if you'd like. But let's go ahead and look at, since we're talking about normal distributions here, let's go ahead and look at number 2 here. It says a machine produces bolts whose diameters are approximately normally distributed with an average diameter of 0.25 inch and a standard deviation of 0.02. Find the probability that a randomly selected bolt has a diameter. See if you can answer some of these questions here. Probably the randomly selected bolt has a diameter greater than 0.24, between 0.2 and 0.3, less than 0.19. Now my hint to you on these normal distribution problems is to first draw out your normal curve. Right? You know that the bolts are approximately, the diameters are approximately normally distributed with this mean, this standard deviation. So draw out your normal curve, locate where the mean is, and then fill out fill out these values along the, okay, just like we did here. So go ahead and try it. And I'll put the table back up. I'll put the table back up in a second, but what I want you to do though is write out a probability statement in terms of z, right? You're going to convert to your standard normal distribution and so does this make sense what we're doing here, or not really, or? So I'll go ahead and fill this in here. So we got 0.25, 0.27, 0.29, 0.31, 0.23, 0.21, 0.19. So for part A, this is the area we want, right? This area right here. Probably that what, x is greater than, what, 0.24? Now if we convert to z, what do we get here? Probably that z is greater than what? You need to convert that 0.24 to a z-score. And if you do that, what do you get? You take the 0.24 minus what? 0.24 minus 0.25 divided by your 0.02. So if you do that, what do you get? Probably that z is greater than what? So negative 0.50? Is that okay? So this area right here is going to be the same as the area under this curve to the right of negative, so here's negative 0.50 here. Okay? So this area is same as this area. So now we have a probability statement in terms of z here, our standard normal. So now we can go to our table to figure out the area under the curve to the right of negative 0.50. And if you do that, we'll use this table, I guess, here. Now, important thing to remember now, your tables, they give you the area underneath the standard normal curve to the left of some z value. So here you want the area to the right. So the area to the left of negative 0.50, what is that? If you go down here, what's it going to be? Well, can't really see it there. What is it, 0.211? Is that 9? What am I looking at? I'm sorry. I'm looking at the wrong thing. I'm sorry. Negative 0.50. So here, negative point. No, I don't know where I was looking. Anyway, negative 0.50. So what's the area right here? That's the area to the left of negative 0.50, right? Right here, 0.3085. Does that make sense? But we want, okay, so we know from our table that this area right here is 0.3085. So what's this then? 1 minus this is going to give us this, right? So what do we have then? 0.6915. How's that? Is that okay? So it means this area here, 0.6915. So this area here is also what? 0.6915. Is that okay? I'll let you try, go ahead and try part B. Now in this one, so point 2 is over here. We'll say point 3 is about right here, let's say. So we want the area under the curve between point 2 and point 3. Okay? So the probability that x is between point 2 and point 3. Now in terms of z, what are we going to have? This is going to equal probability that z is between what and what? If you convert these values here to z-scores, what do you get? Negative 2.5 and positive 2.5, right? Does that make sense? Now we kind of skipped a step here, but just convert each one of these to z-scores. Is that all right? And now we go to our table. Go to the standard normal table and so this is going to equal what? The probability that z is less than 2.5 minus the probability that z is less than negative 2.5. Okay? Now if we go to our tables here, let's go to this one first. What's the area under the curve to the left of positive 2.5? Right, it's right here, right? 2.50. Okay, so that area was 0.9938 minus what? What's the area to the left of negative 2.5? Well, just go to the other one there. Area to the left of negative 2.5 is what? Negative 2.50 is what? Area to the left is 0.0062. So if you take the difference there, what do you get?
0.9876.
0.9876. And that's your answer there. Does that make sense? Just converting to your standard normal distribution, then making use of the table to figure out our area that we need? Okay. And I don't think we need to do part C as well. C, I don't think you have any problem there. Let's look at one that's a little bit different. And this one I'm going to show you now is not on this handout here. But let's think about this. Suppose you take some national exam. You take some national exam, and you're told that the scores on that national exam are approximately normally distributed with the scores on that exam are approximately normally distributed with a mean of 500 and a standard deviation of 100. So if U is equal to, say, 500, standard deviation is, and we're told that the scores are approximately normally distributed. So we can draw out our normal curve here. Okay? And then I come along here and I say, you scored at I tell you that you scored at the 67th percentile on this test. And what does that mean to you? If I tell you that you scored at the 67th percentile, what does that mean to you?
The top 67%.
So that means that 67% of the people who took the exam scored at or below what you scored. Does that make sense? But what I want to know is, though, I want to know what your test score was. I told you scored at the 67th percentile, but now tell me what your test score was. Can you figure out that? I want you to tell me what your score was. I told you that 67% of the people that took it scored at or below what you scored. Well, go ahead and try it on your own here. So think about, now before we get into figuring it out, though, let's kind of ballpark where that 67th percentile is going to be. So is your score, is it going to be somewhere over here between these two? What about between these two? Or what about between these two? What about between these two? You think it's going to be between these two? Does that make? So you want to put a question, we'll put a question mark in here then. Suppose we want to figure out this value here says that the area under the curve to the left is 0.6700. I want to figure out what this value is right here. Does everybody see where we kind of ballparked it there? Because we know the area to the left of 500 is going to be 0.5, right? And then we know that for the area under the curve between 500 and 600 is going to be approximately what, 0.34. So that means the area to the left of 600 is going to be probably what, 0.84. So there, our 0.67 is going to be, it's going to be, our value is going to be in between these two here. Okay? So now let's finish it out here. So what are we going to do from here? How are we going to figure out this score here? We can make use of our z-table. So how are we going to make use of our z-table?
Find 700 and see what your z equals.
So let's see here. So who is helping me there? Over here? Tell me what to, we've got our z-table up now. Tell me what to do.
You find 0.6700. It's kind of hard to see from here, but it's.
Find 0.67 where?
It's
In the body, right? In the body, remember the body of the table, in the body of the table here are your areas under the curve to the left of these z-values. So already remember in the body of the table are your areas under the curve. Okay, so what we're going to look for, got kind of cut off here it looks like. Okay, so where are we at? If you look in the body of the table, you see that 0.6700 is right there. Now, if I give you one where it's not exactly, there, that you just pick the one that's closest in the table. If you had if I asked you for the 88th percentile, for example, you just go and just get the one that's close to 0.8, that's closest to 0.8800 in the table. Okay? And actually, that's a kind of a bad example because actually both of these are. But anyway, but in general though, just pick the one that's closest to the one we're looking for there. But okay, but anyway, let's get back to this one here. Okay, so what do we have here? So what are we going to do now?
Well, you know that the z-score is 0.404, which is
You know the z-score is 0.44, right?
404.
Not 404.
Is it not?
0.44, right?
I want the one that-
The 4, that's your second decimal place, right? And we know how to go from an x value to a z-score, right? To go from an x value to a z-score, so here's our x values here. To go from an x value to a z-score, we take the x value minus what? The mean divided by the standard deviation is going to equal our z-score, right? And here we know what the z-score is what? 0.44? And then you just solve for x. And then if you do that, what do you get? 544. Does that make sense to you? So there we kind of worked backwards, I guess. We got our z-score and then kind of worked backward to get what the x value was there. Does that make sense? Let me give you one to try on your own here. Now this one is a little more difficult than the one I just showed you there, but let's see if you can figure it out here. Number 3, this says scores on a test have a mean of 71 and the score of 80 falls at the 75th percentile. The scores have a distribution that is approximately normal. Find the score that falls at the 39th percentile. So see what you can do with that one. Now one thing here, if you read a question like this, and there's just too many numbers, too much information there too many numbers going around there, begin by just drawing out a picture and see if that helps you. See how you would approach it. Again, if you read the question, there's too many numbers there, it's not really making sense to you, what you're reading, try to break it down, try to draw a picture. Okay, so we know we have, the scores follow what? Normal distribution, right? And you're told that what? The mean is 71. So you can locate where the mean is, right below the peak of the curve there. And then a score of 80 falls at the 75th percentile. So that means you know that the area under the curve to the left of 80 is 0.7500. Okay? And then what you want to figure out, I'll redraw the distribution here. You want to figure out the value that falls at the 39th percentile. So you want to figure out, I'll put it kind of right in here, so this area here is 0.3900. So you want to figure out what that question mark is there. You think you can do it? Now, one thing you're going to need to figure out along the way is what the standard deviation was, right? Figure out what the standard deviation was for the distribution. You can figure that out along the way. Now I'll put the z-table back up for you here. Now, if you look at here, now, here, this is what we're trying to figure out here, this question mark. Says that the area under the curve to the left of this value here is 0.3900. Now, if you think back to that previous problem we just did, that if what we can do here, we can locate go to our standard normal distribution and find the z-score that falls at the 39th percentile. So what is that z-score going to be? So what's the z-score? What is our z-score here such that the area under the curve to the left of this z-score is 0.39? So we're going to look, so what are we going to do here? Look in the body of the table and get as close as we can to 0.3900 in the body of the table. So if you do that, where do we end up here? Right? Looks like right here, right? 0.38. So what's the z-value that corresponds there? So here's the one that's closest to 0.3900, and then get the z-value that corresponds is what? Negative 0.28, right? So here we have our negative 0.28 right here. Does that make sense so far? Let's take a breather here. Are we any problem where we got that? Are we doing okay?
So regardless of what the numbers on your x-axis are, you can always look up the probability in the body of the table.
Yeah, because we're converting, again, any normal distribution we have, any normal distribution we're working with, we can convert to our standard normal distribution.
Okay, and the conversion process
Is
is
it
what
that-
you get up in the table.
Well, to go from an x value to a z-score, you go through that x minus what? X minus the mean divided by the standard deviation, right? That'll convert an x value to a z-score, and then you go to your table, right? So for example, like it here, for example, if we were dealing with, let me just come over here for a second. If we had a distribution like this, it went from what? So 60, 70, 80, 40, 30, 20. So if you had a distribution with a mean of what? 50 and a standard deviation of 10, for example, and I wanted a normal distribution here. If I want the probability that x is between 40 and 60, what I can do is I can convert here over to our standard normal distribution. So in terms of z, what is this going to be? What is this probability going to be equal to? This is going to be equal to the probability that z is between what and what? You convert each of these values here to a z-score by taking the x value minus the mean divided by the standard deviation. So you get -1 and 1. Does that make sense?
So why did you not have to do that for this one?
Well, here we're trying to figure out because we don't really know the x value yet. We're trying to figure out this x value such that the area under the curve, so we're kind of working backwards here. So we don't know. What we're trying to do is figure out the x value. Okay? Yeah.
Do we have the standard deviation value for this?
Well, we'll need to figure that out eventually. But before I get to that though, let's just look. So here, so we know the z-score here is going to be -0.28, right? And we know how to go from an x value to a z-score. What do? You take the x value minus the mean, which was what? 71, but we don't know, we weren't told about what the standard deviation was, right? So, but what we can do here, okay, well, so anyway, let me get to it in a second. Okay, so here, this is what we're trying to figure out, right? This x value. But again, we don't know the standard deviation. But what we can do is we can figure out what the standard deviation was from that other information given in the problem. Right, and what was the other information? It's over here, right? You're told that the value of 80 falls at the 75th percentile. So how can we use this information here to figure out the standard deviation? What am I going to do? So you look up you'll find the z-score for this value of 80 here. So what's going to be the z-score for this value of 80? You look up as close as you can to 0.7500 in the body of the table, and if you do that, what do you end up with? 0.6. Well, it looks like 0.67 will give us the closest one, right? All right, this is a little bit closer to 0.75 than this one. Okay, so here, the z-score we need, so the z-score for 80 is going to be what? 0.67. So you have your 80 minus what? 71 divided by what? Sigma, which is our standard deviation, is going to equal this, right? And then we can figure out the standard deviation. And what does it come out to be? 13.43. And now we can come back over here and fill in the standard deviation, and then we can get our x value. So if you do that, what do you get? X is equal to, put in your standard deviation here, your 13.43, and then solve for x. And what do you get? Anybody get it?
I got 67.24.
67 point, I think that rings a bell to me. Does that look good? Anybody else get that? So that question was a little bit involved. You had to kind of go through a few steps there to, but again, at the beginning though, if you're having some difficulty figuring out where to start, first just try drawing out some pictures and see if that kind of helps you navigate, see how to navigate. Well, that one wasn't easy. But let's try here. Let me let you try. How are we doing on time? We got to 11:50, right? We're doing all right. Okay, let's look at one. This one's not easy either. Look at number 4 here. This one says, let x be a normal random variable with this mean and this standard deviation. And what we want to do is we want to find k such that the probability that x being between 500 minus k and 500 plus k is equal to 0.34. Yeah.
Sorry, just to clarify from the last one, so after you got 13.43, you just plugged it into the right?
Over here. Yep. And then just solve for x. One time I got an email about some guy on a, I don't know if it was a guy or a girl, anyway, on a test, they faced a question something like this and said find k. And then the person said, well, there it is. There it is right there. Anyway, so we won't do that on the, you're not going to do that though. Anyway, okay, so see what you can do with this one. Talk it over with the neighbor, see if you can come up with something here. Now again, if you read a question like this, there's just too much information there. Try drawing a picture. You know you're dealing with a normal distribution. You know what the mean and the standard deviation are for that normal distribution. So fill that in. And you know that the probability that x is between 500 minus k and 500 plus k is equal to 0.34. So how can we use that information to, so give it a shot there. This one's not that easy, but see if you can talk it over with your neighbors and come up with something here. And I'll need to put back up the standard normal table for you. Now, there's one thing I want to reiterate. Now, on the homework assignments, again, you're allowed to work in groups on the homework. No more than 3 persons in a group, but you're allowed to work in groups. And hopefully, working in a group, if you're having some difficulty, you can get help from your teammates there. So you don't have to sit there spinning your wheels. But if you can't get it figured out within your group there, remember there's always you can always get help you can get help from me or my TA. I haven't given you the TA's office hours yet, but I'll post those pretty soon. So for me or my TA, and there's also, you can get help from the Math Learning Center as well. Okay, usually in the Math Learning Center, there's a table that's labeled stat. There's usually should be someone there that can help you out. So you're not alone. The point is, you're not alone. There are resources out there, so don't sit there and spin your wheels when you can get help from someone. Okay? So again, if you're having difficulties, first just draw out your normal curve. Fill in some information here and now we've got this information here that the probability that x is between 500 minus k and 500 plus k is equal to 0.34. So that means that the area under your curve between 500 minus k and 500 plus k is going to be equal to 0.34. So how can you kind of fill that in your drawing here? So if you think about it, I'll just kind of do a rough sketch here so we're kind of going out k in each direction from the mean. So 500 minus k, we'll say that's right here. 500 plus k, we'll say is right here. So you're just going out k in each direction from the mean there. And you know that what's the area under the curve between 500 minus k and 500 plus k? What do we know that this area, again, this drawing is a little bit rough here, but so what do we know this area right here is? 0.34, right? This is just what's given, right? I've just taken, really the only thing I've done here, I've taken what's given in the question and I've just put it into a picture here. And now hopefully looking at the picture here, you can kind of see how to proceed. Oh, sure. And again, try to start bringing your standard normal. These are posted on just try to start bringing these to class from now on. There's your Did that picture help a little bit or not really, or I don't know? How are you doing over here? Are you making progress, or
Yeah, I think so.
are you talking with your neighbor here? He's not helping you out any? Anyway, again, talk it over with your neighbors. And I don't mind you talking, in a situation like this, if you're talking about the Are you making progress here, or do you need a hint? Are you making some progress? That picture didn't really help you too much? No? Let's come back to the picture here for a second. Okay, so let's look at this here for a second. So we know the area under this curve between what? 500 minus k and 500 plus k, this area right here, is 0.34. So what about the area? What can you tell me about the area to the left of, the area under the curve, to the left of 500 plus k? Can you figure out what that area is? Well, first of all, what's the area to the left of the mean? 500. What's the area to the left of 500? 0.5, right? Okay. And then, what's the area under the curve between 500 and 500 plus k? What is that area going to be? What's the area under the curve between 500 and 500 plus k? It's going to be just half of what? The 0.34, right? So you're going to have, you would have 0.17 here, right? 0.17 here. Does that make sense? So what does that tell us about the area under the curve to the left of 500 plus k then? That area is going to be 0.67 then. Does that make sense? Because you know the area under the curve to the left of 500 is 0.5. We've determined that this area right here between 500 and 500 plus k, this area right here is 0.17. So that means the area under the curve to the left of 500 plus k is going to be 0.67. Now you could also work with this value over here, that's over here. You can say that the area under the curve to the left of 500 minus k is what? What's that going to be? What's the area under the curve to the left of 500 minus k? 0.33, right? So either way you can, okay, but anyway, let's just go ahead and work with this one here. So if we know that the area under the curve to the left of 500 plus k is 0.67, what do we know about the z-value for that? The z-value is going to be what? If you go to your table, we know the area under the curve to the left of 0.44 is our 0.67, right? So here's going to be our z-score right here. Our x value is right here. So how do we go from an x value to a z-score? So your x value is your 500. You have your 500 plus k there. That's your x value, right? And then minus what? 500 divided by what? 100 is equal to what? What is this equal to? You're just converting this 500 plus k is your x value, just converting it to a z-score. So what's the z-score? We know what the z-score is, right? It's 0.44. Right? Now you can just solve for k, right? So what's going to happen here? 500s are just going to what? They're just going to drop out, right? And you're going to just be left with what? K is equal to, well, all the dust settles. What do you get? 44. Anybody get that? Did you? Who got it? Did you get it? All right. Did you get it over here? You got it? All right. Anybody else? That one wasn't easy now. Again, but hopefully again, just drawing out the picture helped a little bit though. It doesn't seem like it helped a whole lot, but hopefully it helped a little bit. Okay, let me let you, here. How much time we got here? We got 5 minutes here. Do we want to do an easy one or a hard one here? What do we want to do? Let's do a harder one here since we've got 6 minutes here. Let's try it as a class. So let's look at this one right. I think we have 6 minutes, right? Yeah. Let's look at 5 here. 5 says, now this one, you may have to use some algebra, you're going to have to use some algebra skills that maybe you haven't used in a long time. Let's go back to those old algebra days. We love those days, right? Let's close our eyes for a second. Actually, my daughter's, tomorrow's first day of high school tomorrow for my daughter. Oh boy. Remember those days? Were those good old days? Not really. What can I tell my daughter for some words of wisdom? I don't know. Don't go to high school or what? Skip that old high school experience? I don't know. Maybe it's not that bad, was it? Was it bad? Pretty bad, huh? Anyway, we won't go back to those days. Okay, so let's come here. So the distribution resistance of resistors of a certain type is known to be normal, with 10% of all resistors having a resistance exceeding 10.634 and 5% having a resistance smaller than 9.7565. Now what you want to figure out, what are the mean value and standard deviation of the resistance distribution? So here you've got a couple of unknowns here. You want to figure out the mean and the standard deviation for the distribution. And what are you given here? So again, if you don't know where to begin, let's just draw it out here. You're told that 10% of all resistors have resistance exceeding 10.634. So if I draw out 10.634 here, I know the area to the right over here is 0.10. Is that okay? Is that okay? And I also know that what? The area to the left of 9.7565 is what? Well, let's draw this out a little bit further here. I'll make it a little bit. Okay, and then this one is what? We'll say is, this area here is what? That one's 0.05, right? That's just what's given, right? That's given in the question. So can we go from there? So what we can do is we can figure out what the z-scores are for these two values, right? We can do that, right, from our table. And then we can do we're going to figure out the z-score. We know the x value here in each case. So you're going to end up with two equations, two unknowns, right? Does that kind of see how that's going to play out? Go and try it. So let me put up so what's going to be the z-score for, so this x value here is going to have what's the z-score going to be for that x value? Let's go to our table here. We'll look up as close as we can to 0.0500 in the body of the table. So what do we end up with here? Get as close as you can to 0.0500, and where's that at? Well, it's actually kind of halfway, it's right in here, kind of halfway between. So this one, just to be a little bit more exact here, for this we often use a z-value of negative 1.645 for this one here. You ordinarily you don't have to carry out that many decimal places, but anyway, actually this, are we going to run out of time? We still got 2 minutes here. So what do we got here? So you're going to end up with 9.7565 minus what? Mu divided by sigma is going to equal what? What did I just say? Negative 1.645. That's one equation. And then for the other one, what are we going to have? The z-score for this other value, what's going to be the z-score for that one? Well, if the area to the right of this value is 0.1, if the area to the right of this value is 0.1, what's the area to the left of this value? 0.9, right? So we need to look at 0.9 in the body of the table and find the z-value that corresponds there. So let's get as close as we can to 0.9000, and what is that one? I think it's going to be right over here, right? The 1.2, it looks like it's going to be 1.28 is the z-value that we need. So does that make sense? Because if the area to the right of this value is 0.1, the area to the left of this value is 0.9. Because the area under the whole curve is 1. We know the area to the right of this value is 0.1. So that means the area to the left of this value is going to be 0.9. Is that okay? So we get our z-score. So you got your 10.634 minus what? mu divided by sigma is going to equal what? 1.28. So here we have our two equations here, two unknowns. Do we remember how to do that? Oh, we do, right? Let's go back to those algebra days. What can we do here? How can we solve? You can do old substitution method, or there's different ways you can do it. Think about, one thing that might help you here is just, if we rewrite this here, let's rewrite it like here. For this one, this first equation, if we rewrite it as, okay, so mu, I'll bring mu to the other side, okay, multiply both sides by sigma, and mu to both sides. So if we had mu, and then minus 1.645 sigma is going to equal what? 9.7565, right? I just rewrote this, okay? And then the other one, we're going to have what? Mu plus what? 1.28 sigma is equal to what? 10.634. Does that make sense, what I did there? I just rewrote these. So we have these two. Is that okay? Does that make sense what I did there? Just rewrote those. So if we have these two here, what's one way to, you could actually, if you subtract the second equation from the first, what's going to happen? What's going to happen to the mu there? What's going to happen? You'll get rid of the mu's, right? Mu minus, you see what? I just subtract the second equation from the first. You remember doing it this way, or? I don't know how you learned it. You can do the substitution method too. You remember how you learned it? Back in the out. Can you finish it from there? I don't know how you learned it this way. There's different ways you can. Do you remember though? Yeah. Anyway, I wouldn't give you a question like this on an exam though. These skills here maybe you haven't used in a long time or something. So, but see if you can finish it out though.
So you could just isolate mu?
Well, here, if you subtract the second equation from the first, you're going to get rid of mu, right? Because mu minus mu just 0, right? Just drops out. So you're just left with this minus this.
Why are you subtracting?
So then I can get rid of mu. And then I just have sigma in our, and then we can figure out what sigma is and plug it back in to figure out what mu is. Does that make sense?
I was just confused as
it
to
doesn't.
why.